All right, so let's go ahead and work on this problem. And when we study this problem, these kinds of piecewise functions give students some trouble when we ask them to graph. So let's go ahead and see why that might be the case. And then we'll use a graph to think through what it is that we are trying to accomplish. So just for the sake of simplicity, I think I'm going to start with this piece because it's basically the line y equals negative x. So that should be fairly easy to do. It's a line that slopes downward, but importantly, it's going to start somewhere about here. Assuming that this is negative 1. So and of course, we're starting at negative 1. So that's the curve there. The other piece may be a little more. I was going to try to make that better, but let me just see if I can leave it like that. The other piece may prove to be just a tiny bit more challenging. So let me work on it. I guess we can do it over here. Let's say, since I used y on the other one, I'll do the same thing over here. We'll say, okay, well, that's y is 2x squared plus x. And what I'm going to do is factor out the x. So I should say I should do what I said I was going to do. Factor out the x, and we're left with 2x plus 1. And this curve then has two zeros, one at x equals 0, and another one, if I set this equal to 0, then 2x is negative 1. So x is negative 1/2. So I don't know how helpful that is going to be to us. I want to get a sense of what this curve was going to look like. And I thought that would be somewhat helpful for us. And I'm never sure how to use that curve function. So I'm just going to sketch it out freehand, and it's not going to come out very good, but it goes something like this. Okay, and you have to imagine this goes under just a bit, but like I've done in other examples, we don't really care what's going on over here, actually. But it appears just from my very rough sketch that there's some disconnect there. But this is supposed to be, a parabola, even though now it looks like a line. But because there's a disconnect, we're just gonna have to plug it in. There's no other way to do it. So let's go ahead and find the limit. By the way, when I say plug it in, that we're gonna have to use the appropriate function and the appropriate rule. So this would be 2x squared plus x as x approaches negative 1 from the left first. So I'd have to use the parabola part because that's what's associated with approaching from the left. And so you are by the rules, this is basically f of a as x approaches -1 from the left. And where this is the a, so then 2 times -1 squared plus -1. So this is 2 times 1 minus 1, which is 1. Which is 1, if I did that right. And it's always good to double check. All right, so I'm beginning to think that maybe my picture is not as accurate as I would have liked it to be, but that's okay. So now the limit of f of x as x approaches -1 from the right, we need to do f of, instead of using a like I did over here, I'm gonna just say plug in the -1, and using the appropriate piece, that means I use the right side. So I wrote it down over here, which is the same as this over here. So it's -1, which is 1. So they actually have the identical limit. So my picture was not very good because these actually do coincide. And I don't know if that fixes things, but they do coincide. So in fact, the limit is 1.